you were supposed to plot the points of sine. It's in degrees, which makes our life a little bit easier. So, if you did it, if we just click on Winnie, thanks Winnie. Oh, my bad. Not supposed to see the name. I can't get her name out. So it should look something like this, having that perfect sine wave to it. Are the y values perfectly spaced apart? No. As you move over, it's not perfect. It's not like a if I increase by 30, I go up by this much. It doesn't increase perfectly like that. So um, don't be stressed that like from 0 to 30, it's jumping all the way half, and then from 30 to 60 it's jumping less than a half. Okay, so it should have this wave shape to it. Looks great. So I'm going to go ahead and release one more slide to you guys. So from here, what you can do is it says type the function y equals sine of x, and when you submit it, what should happen is it should outline the perfect points that you had. So if I click on um, Julio, great job Julio, it went through their points perfectly. Okay, great job. So hopefully that's making a little bit of sense. That's what sine looks like. Now cosine specifically, you probably didn't do it yet, and that's fine with me. I'm going to yank us over. I'm going to stop the pacing and yank us over to slide 4. So don't get all stressed. These first couple won't be for a grade, so don't be all stressed if you didn't get it. Didn't get it in there good. So cosine of x. What's the biggest difference between sine and cosine? Great job. Yep, sine's going to start at 0. Cosine's going to start up at 1. And notice it's got that half hill there, full valley, and then a half hill to make that period from 0 to 360 degrees or 0 to 2 pi. Okay. Um, a lot of us are putting our x's like this for our points. We're doing x, x, and then they're at 180. They're putting another x right there because for sine, that's what you did on the x-axis, right? It was like 1, 2, 3, all perfectly together like that. But for cosine, again, it's different. You want to have the x down there, and then there's two x-intercepts in between. Okay. So again, you don't need that x up at the top, and then your first x-intercepts at 90, and then 270 to make your 5 points for your period. Okay. Okay. So hopefully that's making some sense. If we go to slide 5, okay, it says the pattern continues as you continue to make rotations around the circle. So again, the pattern never stops because we're just going around and around the circle. So if I did stop it at whenever it stops, it should stop soon. I think it stops at like 1500. 360 times some number is going to get me really, really close to one of these numbers out here. Okay. Either right before 1200, at 1350, or after 1500 there. Because again, we're just going around and around the circle. That's why it makes that same shape forever. Now, if we look at an example, the thing we need to see today that's new for the first time is on this slide right here. As you're staring at that red equation, is that jumping out sine to you or cosine to you? Sine, because it's starting at 0. What's the amplitude look like? How big? It goes up to 1, down to -1, so that amplitude is just a 1. What's it look like is the period length. Talk to your partner for a second. If you had to tell me how long the period is, what would it be? Tell your partner for a second. The temptation is to just go all the way out to the edge, but remember, the period length is one full hill, one full valley, so it's just 2 pi. If the period's 2 pi, what is your b value? A 1. What do a lot of people say instead? They tell me 2 pi usually, maybe 0 as well, but they tell me 2 pi as the b value. So make sure that you see that the b value is 1 because the period is 2 pi. Now, if I had to plot these points here, it says graph these 2 points here. So sine of x plus 1, I'm moving everything up 1. So I'm putting a dot at 1, another dot at 2. I have to sneeze. Okay, so we went from 0 to 1, pi over 2 to 2. Pi goes up 1 as well. 3 pi over 2 comes up 1, and pi over 2 comes up 1. Remember, it's not one box, it's one complete unit. So I'm going to connect those dots. I'm just going to do the first 5. Making my full period. Somebody asked a great question in third period. They said, are those lines parallel? It's honestly a smart thought. Are they ever going to cross? A lot of times you guys have said parallel lines are lines that don't cross, right? They're not parallel, but they got to be straight lines. Yeah, this isn't a line. Technically, this is a curve. So maybe you could get away with parallel curve. I think that's still not like mathematically the word, but again, these lines would never ever cross. Okay, so now this is the new part for today, right there. Okay, the new part is now where we've got something inside the parentheses after the x. What do you think that's doing to the graph? Shifting it right and left. Since it's a negative, which way do you think it's going? Right, because it's of that inside opposite concept. Great job. You're pulling in stuff from last semester. So if I get rid of the so if this is telling me to go right pi, if I'm trying to go right pi, I go from 0 to pi. Good job. I go from pi over 2 to 3 pi over 2. I go from pi to 2 pi, 3 pi over 2 to 5 pi over 2, and 5 pi over 2 to 7 pi over 2. Now, it gets a little bit confusing because, oh, it's so cool. It really is cool. If you don't think it's cool, you're lame. That this graph right here, if I connected it back to the origin, shifting right pi is the exact same equation as what? If you stared at the blue before today, what would you say is happening to change from the red to the blue? It's just a reflection. So negative sine of x is the exact same equation as sine of x minus pi. Kind of cool. A little nerdy, but that's okay. So hopefully you're seeing that. Now, this is my last slide and then I'll stop talking. So play around with the slider for just a second. Again, that h is on the inside and it's affecting how we shift the graph. Okay. That h is on the inside affecting how we shift the graph. Well, let me pause. So as you're playing around with the h slider, okay, 3.1 looks like DNA. I agree. So how much was it shifted? It was shifted about a pi, about a 3.1. Great job. And now somebody in third period, I'll let them remain anonymous, was like, oh my gosh, 6.2 is cool. And I was like, that was the nerdiest thing I've ever heard that person say. 6.2/6.3 ish lines it up perfectly. Why is it lining it up at 6.2? Double what? Double of pi. Well, it's the same thing as double pi. 360. So it's a full rotation shifted over. So now it's laying perfectly on top of itself again. Okay. Kind of interesting. Now, that's all I've got in terms of new content for you today. We'll work with that shifting thing tomorrow.